Okay, I want you to forget everything you see outside your window for a minute. We're going to go on a journey way, way back. A time before there were mountains, before oceans, heck, before the air you're breathing right now. This is it. This is the origin story of our planet. It's an epic tale of cosmic fire, violent creation, and just an incredible transformation that made our world home.
I mean, have you ever really stopped to think about it? How did all of this, our world, our home, how did it actually begin? It's one of the biggest questions we can ask, right? And the answer? Well, it's a story that was literally written in the stars, billions and billions of years ago.
So to get to the very beginning, we've got to rewind the clock, and I mean a lot. We're talking 4.6 billion years. Just try to wrap your head around that number for a second. It's almost impossible to really grasp, but that's where our planet's incredible story kicks off.
All right, so first things first. What's kind of wild is that our story doesn't actually begin with Earth. Nope, it starts with the entire solar system. See, to really get a handle on our world, we first have to go back and understand the cosmic nursery it came from.
So everything, and I mean everything, our sun, our planet, you, me, it all started right here, in a nebula. Just picture this, a gigantic, swirling cloud of gas and dust just floating out there in the blackness of space. This is it. This is the birthplace of stars and all their future planets.
So the big question is, how does a cloud turn into a whole solar system? Well, it all kicks off with gravity. Gravity starts pulling that massive cloud inward, tighter and tighter, until it collapses under its own weight. Bam! Right at the super dense, hot center, a star ignites. That's our sun. And all that leftover stuff, the dust and rocks swirling around it, that's when it starts to clump together. You know, there's a name for this clumping process. It's called accretion. And honestly, the best way to picture it is to think about a tiny snowball rolling down a really big hill. It just keeps getting bigger and bigger as it picks up more snow, right? That is exactly what happened out there with all that cosmic dust and rock. These little clumps got bigger, forming these baby planets that would one day become the planets we know, including our own early Earth. Okay, let's jump into the next chapter. Because once Earth really started to form, oh man, it was anything but peaceful. We're talking about a period of just extreme violence and insane heat. It was quite literally a trial by fire.
Yeah, it's really hard to even imagine. You know that beautiful blue and green marble we see in all the pictures from space? Forget it. Just completely erase that from your mind. The early Earth was a totally different beast. A chaotic, glowing ball of superheated rock. Look, to put it bluntly, it was a molten hellscape. Seriously, the entire surface was just this churning, global ocean of melted rock. There was no air, no water, no solid ground to stand on, nothing but just unimaginable heat and pure cosmic chaos.
So, why was it so crazy hot? Well, there were basically three things going on. First, the early solar system was like a cosmic shooting gallery, and Earth was the target. It was getting constantly smashed by meteors and asteroids. Second, you've got gravity just relentlessly squeezing the planet, which generates a ton of heat. And third, deep inside the Earth, radioactive elements were decaying, which released even more energy from the inside out.
But here's the cool part. Out of all that fiery chaos, order actually started to emerge. While the whole planet was still this molten mess, something really crucial started to happen, something that would give our world the exact structure it has today. And it all came down to one simple thing: density. You know how oil floats on top of water? It's the exact same idea. All the molten stuff on this baby Earth started to separate. The really heavy materials, stuff like iron and nickel, they sank right down toward the center. Meanwhile, the lighter stuff, these silicate rocks, they floated up toward the surface.
So scientists call this whole process planetary differentiation, but I like the other name for it, the Great Separation. It's pretty fitting, right? As all the heavy stuff sank and the lightest stuff rose, the planet basically started to organize itself from the inside out. This was a huge moment. This is when Earth went from being just a uniform molten blob to a structured world with distinct layers.
And what was the result of this great separation? Well, you got Earth's three main layers. Down at the center, we have the superdense core. Wrapped around that is the thick, rocky mantle. And then on the very top, you have the thin, solid crust. You know, the part we're all standing on. The basic structure of our planet was finally locked in.
Now, this wasn't just some neat geological tidying up. This was absolutely critical for life. And here's why.
That swirling liquid iron core, it created Earth's magnetic field. Think of it like an invisible shield that protects all of us from the sun's nasty solar wind and radiation. So yeah, this ancient event is literally the reason life can even exist on the surface today. No big deal, right?
Okay, so the inside of the planet is all sorted out. Now the action moves to the surface. But Earth was still missing a couple of key things before it could be a real home. It needed an atmosphere, and it needed water.
So where did our first atmosphere come from? The answer is volcanoes. The early Earth was just a volcanic nightmare. Its surface was covered in cracks and vents, just constantly spewing this cocktail of gases from deep inside the planet. We're talking mostly water vapor, carbon dioxide, and nitrogen. This relentless outgassing from volcanoes is what created our planet's very first and very toxic atmosphere.
Now think about it. All that water vapor being pumped into the air by volcanoes had to go somewhere. As the planet's surface finally started to cool down and harden, that vapor condensed into these massive planet-covering clouds. And then it started to rain. But this wasn't just an afternoon shower. This was a rainstorm that lasted for millions of years. A continuous global downpour that slowly filled up all the low spots to become the very first ocean.
And that brings us to the final chapter of this origin story. Let's just take stock for a second. We've got a solid internal structure, we've got that protective magnetic field, we've got an atmosphere forming, and now we have vast oceans. The stage was finally set for something truly mind-blowing to happen. Life. Honestly, you can think of it like a recipe, a cosmic recipe for a habitable world. You needed these three key ingredients to turn Earth from just another dead rock in space into a planet that could actually support life. You needed liquid water in the oceans, a stable atmosphere, and, of course, a steady source of energy from the sun.
So let's just do a quick flyby of this incredible 4.6 billion-year journey. It starts with a nebula collapsing to form the sun. Then Earth forms through accretion. It turns into a molten world, which then separates into the core, mantle, and crust. Volcanoes pump out an atmosphere, and millions of years of nonstop rain create the oceans. And boom, the stage is set for simple life to finally show up. Every single one of those steps was absolutely essential.
I mean, what an absolutely amazing journey, right? To go from simple space dust to this vibrant, living planet. It's really awe-inspiring to think that all the complexity and beauty we see around us today came from such chaotic, fiery, and honestly, humble beginnings. And that kind of leaves us with one last thing to chew on. Our planet's story is really one of incredible luck, isn't it? It's all about perfect timing and being in the perfect location in the cosmos. Just think about it. What if things had been just a tiny bit different? It's a pretty powerful reminder of the incredibly delicate cosmic balance that makes our world and our own lives possible at all.